Hello, this is Mr. Wynn, and I just wanted to do a quick run through of domain and range and what you do if you've given a discrete function, or if you're given a continuous function, or even a real life situation. What would I do? How to find the domain and range, right? And just as a reminder, domain is your set of all x values, all right? So any x values, all x values possible. Range is all set of all y values, so any y possible, all the y values, whatever. If it's a discrete function, that means it's kind of broken up. It's just points, right? It's not including every single point. They're discretely, across your table, graph, whatever. That means I'm just going to list every single x. So say if I give this discrete function where there's 3 points, right? This example here, right? How would I label all the x values? Well, right, where are the x values? 2, 2, 5, the first number in those ordered pairs. Just list them, all right? So I'm going to write D for domain, all right? And I'm going to list in a little bracket, little brace, 2, right? Well, I have 2 2s, right? So let's just label it once, and then 5. The key thing about listing is you always got to remember they have to be in order from lowest to greatest, and you don't want to repeat any numbers, right? It's kind of redundant to say, I'm going to use 2, I'm going to use 2, I'm going to use 5. Well, you already told me I'm going to use 2. Do you really have to say it again? Yeah, I'm just going to use 2 and 5. Now, I might use 2 more than once, but, the all possible x values, the domain is just going to be 2 and 5. I don't need to, say both. All right? Range are these second numbers. So here, 5, -3, and 7. So again, list those in order from least to greatest, all right? So I'm going to write R for range. Let's put a little brace, right, saying that it's a set of these values. So the lowest would be -3. The next lowest would be 5. And the greatest would be 7. So I'm going to close that brace. So our range values, the only possible y values you would use are -3, 5, and 7. All right, what if you had a table? Well, same thing, all right? Domain are still going to be your x values. It's still discrete, right? There's certain points. They're just structured, right? These are just ordered pairs, but in a structure where all your x's are on the left, all your y's are on the right, okay? So in this case, the domain, I'm going to list every single x. So I'm looking at these values here, right? But I'm going to list from lowest to greatest. Now, the thing about tables are they're structured to where your x's, your independent values are, in order from lowest to highest, right? It's easy to look at. So let's just list them going down because it's already in order. Excuse me. The lowest would be -3. Next lowest, -2. Next lowest, -1, 0, and then 1 is our greatest value. All right? Let's do range, R for range. Well, I've already listed the x values, right? That's the domain, right? So it should make sense. I'm going to list the other values, the range, right? So from least to greatest, lowest to highest, would be 2. All right, I've listed 2, and then I'm going to list 5, right? There's 2 of them, but again, don't got to be redundant. I'm going to use 5, that's what I'm saying. 14, and lastly, 29. All right, those are your domain and range values if I give you ordered pairs or a table. Now, what if it was a continuous function, right? Looking like this. There's a graph, it's continuous. It's not broken up into points. It means every single point between this. It can be from 2, 2.1, 2.2, 2.3, 2.4, everything in between, right? It's impossible to list every single one of those. That's why it's a continuous function. And this is when we'll need to list the lowest to the greatest and then say everything in between is our domain, right? So if I wanted to find domain, all right, D for domain. All right, easy way to do this is kind of highlight your regions, right? So highlight the left to the right, okay? Because domain is x going left to right. So let's just highlight the very left. All right, so here's the very left, right? I'm not going to use any of this section here, right? Here's the very right. All right, I'm not going to use any section here, right? And look at what's the lowest, what's the greatest. Well, if I go down, right, to the x, that line, right, that section I, set off to the left was at 2. So in this case, your lowest value is 2, okay? Now notice how the circle there, that point, it's an open circle, right? It's not filled in. That means it does not include that point. So when we write our inequality symbols, we want to write less than, right? Just less than, not less than or equal to, right? Don't put that line underneath. Just think if it's not filled in, right? Don't put a line. Don't complete that sign. Okay, now we know domain is x values. Let's figure out the highest. So if I go over here, if I go down, right, that's at 5, right? That region to the right is 5. That's our greatest, right? I'll put a 5 here. But in between that, I'll put less than or equal to, because that point is closed in, right? It's a solid point. It's filled in, right? Okay, so we put a line underneath. It's less than or equal to. So what this is saying here is that your x, right, is literally in between your 2 as your lowest, 5 as your greatest. Okay? Do the same for range, right? I'm going to list range. And I'm going to do the same. I'm going to list the lowest to the highest. But for range, we're going to look at the very bottom of that graph and the very top of that graph. So if I highlight this very bottom, right? Right, that's the very lowest the graph will go. I'm not going to use any of this at all. This is the very highest. Right, I'm not going to use any of this graph at all. So the very lowest, looking at the pink region, right? If I go over here, the very lowest is going to be 2. So 2 again. And again, notice that point that I'm looking at, referring to, it's open. So just the less than symbol, right? In this case, it'll be a y. And then again, let's figure out the highest. Over here, that top region of the pink area I highlighted, that's 5. The highest will be 5 as well, but it's a closed point, right? Remember, that point is closed, it's filled in. So in this case, it's going to be less than or equal to. So your domain is between 2 and 5, right? Not including the 2, but includes the 5. And then the range is also 2 to 5, but it doesn't include the 2. That's why it's this little open circle. And it includes the 5, so there's a less than or equal to sign towards the 5. All right? Now, what if I give you a situation, a real-life situation, right? What if I wanted to go to the state fair? All right, I've got $40. So Mr. Nguyen has $40 to spend at the state fair. Mr. Nguyen wants to only go on rides at the fair. So forget about all the food and all the other attractions. I'm just going to go on rides. So admission into the fair is $15. Right, so I got $40. I know I got to pay to go in, right? So really, I can't use all $40 to go on rides, right? Okay, well, let's just keep reading on. Each ride costs $4. Then it asks, what is the reasonable domain for R? So R is going to be our domain values, the X. The number of rides Mr. Nguyen can go on. So again, like I said, I have $40, right? Now I got to get into the fair, right? It costs about $15. That sounds about right. So I got to take away $15 from that $40, correct? And if I take away 15, so really, I can only spend $25 on rides. Really, that's all I can go. That's all the money I have left after I've paid the interest to go in, that interest fee. All right. So now let's think. I've got $25. Now each ride costs $4. So really, how many rides can I go on? Well, I could divide by 4, kind of figure that out. But do I really have to go on any rides at all? We're talking about the reasonable domain, the all the set values of X, right? What makes sense? I don't have to go on any rides, right? I could go there and look at all the rides and think, well, none of those are really appealing. I'm just gonna save my money. Let's not go on any rides at all. Let's just chill, have fun with friends, whatever, right? Not go on any rides. So let's just make a table, okay? I know I don't have to go on any rides. So X, well, let's just say R. In this case, R for rides. And then whatever your function of R is, all right, however much it costs. So your rides, I can go 0, right? That means I'll get to keep all my money. I get $25, right? What if I go on one ride? Well, I'll take away 4 from that, right? That's possible. I could want to go on one ride. So I'll take away 4, I've got $21. 2 rides. Well, take away 4 again, 17. 3 rides, right? I can go 3 if I wanted. That'd be, all right, take away 4, 13, right? And then I can go on another ride. Well, 4 rides. All right, I'll be left with $9. I can go on 5 rides, sure. I'll be left with $5, right? I can go on $6. Yeah, I got $5 left. I'll have $1 left over, but if I try to go on 7, I don't have enough, right? Right? That'll be what, like negative, take away $3. I still need another $3, right? So thinking about it here, right? 7 is not possible. What's reasonable, what makes sense are either 0 or from 0 to 6. Now, of course, I can't say from the lowest to the highest because you can't possibly go on half a ride, right? You don't want to list the numbers in between, half a ride, a third of a ride, anything in between, right? So what I'm going to do, this is actually a discrete function. I'm going to list as my reasonable domain all the x values. So what makes sense? What's reasonable? Well, the domain values, all set x values are going to be from lowest to greatest, right? 0. I could go on 0 rides, 1 ride, 2 rides, 3, 4, 5, and 6, and then I can't go on 7. That's the highest value I can go on 6. I'm done. Even though I have money left over, I can't go anymore. I can't go 0.25 rides at all, right? 0.25 doesn't make sense. Even if I try to divide 25 by 4, that's what I get. Can't do that. This is our reasonable domain. That would be your answer. The value is 0, 1, 2, 3, 4, 5, and 6. That's what makes sense for our domain. That's how many rides I can go on. All right. Thank you.